Hey young brother chemist, how you doing? This is Coach Scott with Purple Wave Chemistry. Today we're going to talk and do a real quick video on types of reactions, right? Types of reactions. So let's look at our first one. And there's 5 types that we're really going to need to worry about. Okay, the first one I have here is synthesis. Let's get a pen. Alright, so synthesis or composition or combination or something along that line, right? Whatever you want to call it. It's where if we've got one thing by itself on the reactant side, and we have another thing by itself on the reactant side, left-hand side, then it combines to make one thing on the right-hand side, the product side. So if you think about it, so I've got sodium metal, and I burn that in chlorine gas, and of course that Cl2 is diatomic because I have no fear of ice cold beer. Alright, and then that's going to form sodium chloride, NaCl, and H plus 1, chlorine is minus 1, so we're good. Let's go ahead and balance that. I need 2 chlorines on this side. So I've got those. That means I have 2 sodium. So let's look at this here. So sodium, A, decides to ask chlorine, B, to the dance. So they go to the dance, and sodium and chlorine starts dancing together, AB. They're good to go. So our next one is decomposition. So decomposition, is pretty much the opposite of composition, combination, synthesis. It's almost like desynthesis. Alright, so you've got AB. Alright, they're at the dance together. They're on the left-hand side. They get in an argument and they decide to break up. So A goes on their way along with B going on their way. Let's take this again. So if I have NaCl, go to the dance together, and of course they're going to break up, and Na be by itself, and then chlorine will be by itself. Of course that's Cl2. Let's balance that out. I'd have to have 2 NaCl's over there, 2 over there. And so think about it. I've got AB. They're at the dance together. They're dancing. They don't like each other. They found out. So they split up into the A and the B on the product side. So that's the decomposition. The next one would be single replacement or replacement, right? So single replacement is like this. Let's use a different color. Let's go with purple. Right? This is Purple Wave Chemistry, as you know. So single replacement. Single replacement. Let's go back with our dance analogy. Okay. So you've got A all by itself, right? And they went stag to the dance along with B and C. Well, A and B are friends, and A really wants to dance with C. So A goes up to B and says, "Hey, mind if I dance with your lady?" So B, being a nice guy, lets him dance with his date for the evening. So B sits by itself for a dance, A and C dance together. Let's think about that, okay? So let's say we have iron. Do an example. Iron, Fe, is by themselves, and then copper to chloride, CuCl2. Okay, they are dating together, or they are dancing together at the dance. Iron goes up to copper. We'll call this A. Copper is going to be B, and chlorine is going to be C. Iron, the A, goes up to copper and says, "Hey, can I dance with your lady for one dance?" And they say, "Sure." So copper goes by themselves, and they sit at the end of the dance and just sit out one dance, and then iron 3, Fe, plus 3, Cl3, they dance together. So of course now B, copper, is watching A and C dance together. So let's go ahead and, because we want to do what we're supposed to do, we're going to go ahead and balance that. So, okay, I'm going to put a 2 there, 3 there. That gives us 6 coppers. So I need copper chlorides, or excuse me, 6 chlorines. That means I need a 3 there, and I need a 2 there. So that's a single replacement. Iron, iron, iron goes up to copper, their buddy, and says, can I dance with your date? Copper, being a nice guy, sits out a dance, and iron dances with the chlorine. Everybody's happy. Okay, let's look at one more, the double replacement. This is the 4th one out of the types of reactions we're going to deal with. So this is the double replacement. Similar to the single replacement, a little bit more complicated, but I think this is the easier one to identify. Here, on the single replacement, you got one thing all by itself, okay, on the reactant side. Then you have something together. Then you have something different all by itself on the product side, and then something together. Here you've got a very big reactant, you've got very big products, right? So you've got AB, they're dancing together, and you've got CD. So they're a fun, loving couple there. So they said, hey, I'm tired of AB is tired of dancing with A is tired of dancing with B, C is tired of dancing with D. So A and C talked together and said, hey, let's switch up a little bit. So C will dance with B, and A will dance with D. So A dances with D. Let's look at an example. So I've got calcium chloride, Ca, Cl2, and I know it's 2 because calcium is in group 2, so it's got a +2 charge. Chlorine's got a -1, so that would be CaCl2 is dancing with AgNO3, silver nitrate. AgNO3. Of course, nitrate is a polyatomic. I look at nitrate, and I see from my list of ions that nitrate has got a 1 minus, so that means silver has to be +1. Nitrate is -1 because they're there together. Okay, that's cool. Come into play later. Alright, so silver and calcium chat together, and so of course these are aqueous, so let's put AQ in here. AQ. They're mixed with water, dissolved in water. That's what we mean by aqueous. Aqueous. Alright, so the calcium and silver talk to each other. These are both soluble in water. Calcium and silver talk, and silver says, hey, I'll dance with chloride, you dance with nitrate. Okay, so calcium, being the nice guy he is, dances with the nitrate. So now you have calcium +2, nitrate -1, so you need 2 of those nitrates. Okay, and that's aqueous. Okay, and of course you got silver chloride. Silver is +1, chlorine is -1. Chlorine is -1. Go back over here, silver chloride, Cl, +1, -1. But this falls out of solution as a precipitate, right? So calcium and silver talk to each other. They switch up dancing with nitrate and chlorine. So AB, calcium being the A, chlorine being the B, dance with C and D. Silver being the C, they decide they switch up. Okay, so calcium dances with the D, nitrate, and then silver, the C, dances with the B. So that's the double replacement. The last one I think is the easier one. It's combustion. Okay, So in combustion, cool green. All right, so combustion. No dancing here. So in a combustion reaction, all right, you've got something combining with oxygen, usually a hydrocarbon. What's a hydrogen? Something that has hydrogen and carbon. Let's say C3H8. Okay, so you have hydrocarbon CH, let's just say CH. It's going to burn in air, which means it's going to burn with oxygen, or O2, of, I have no fear of, okay, and it's going to produce two products. Always it's going to produce two products. Alright, your products are going to be carbon dioxide. And I say always, that's one of those rules of chemistry, and then there's exceptions. It's going to produce carbon dioxide and water. If you got carbon dioxide and water as your product, you've got one of your reactants is oxygen. Guess what you got? Combustion. Alright, so let's look at one. Let's say I've got C3H8, and I burned that in air, which means I'm burning it, reacting it with oxygen. And I'm going to form, guess what? CO2 and water vapor. I've got a combustion reaction because I have CO2, carbon dioxide, and water. Now let's balance it because that's what we do. So I need 3 carbons on this side. So I'll put a 3 there. That gives me 6 oxygens. And then I need 8 hydrogens on this side. So I'm going to put a 4 there. So I've got my 8 hydrogens. I've got my 3 carbons. So oxygens, I've got 6 and 4. 6 plus 4, that's 10. So I need to put a 5 there. So I've got no A, B, whatever. I've got a hydrocarbon burning in oxygen, and I'm producing carbon dioxide and water. So that's all there is to that, guys. Okay, that is combustion. And those are your 5 types of reactions. And I think you'll be able to handle these real easily. Just look for what I'm telling you. Okay, you got your synthesis, 2 singles on the reactant side, they combine together for one product. Decomposition, you have one reactant that splits up, then you have decomposition. Single replacement, you have one single by itself, you have replaces one thing on the reactant side, and then you got something different by itself on the product side. Double replacement, you got 4 big things, and they flip, they switch up with each other. And of course combustion, I think it's pretty easy. You've got you got a hydrocarbon, you've got oxygen on the reactant side. Your 2 products are always going to be CO2 and water. So anyway, that's all for today. This is Coach Scott saying have a great day, and hullabaloo, connect.